Hi girls. So what I wanted to do today was just to show you a quick example of how to make a mind map. So one of the things that I've asked you to do recently is to look over some notes, draw a mind map, and then try some questions. And the mind map bit sometimes is a bit of a problem for people. Sometimes for some topics it can be relatively easy because you're just regurgitating the information you've learned, but for some things it can be a little bit more complicated. And one of those things sometimes is moles, because moles is a little bit abstract. So what I wanted to do today was to just have a quick look at how we might make a mind map all about moles. And it's a good idea for you to try to do this over the next while if you can, before you try some questions from an exam paper or whatever. So if you were to make a mind map about moles, what would you be doing? Basically what you're doing is you're trying to explain to somebody, they can be imaginary or real. If you have a volunteer at home, even better, but if you don't, you can just imagine you have somebody with you like I'm doing now, and explain to them what moles are and how we use them. And how do you start? Well, I suppose the first place to start is to say what exactly a mole is. And a mole is just a number. It's a very big number. It's 6 by 10 to the 23. So the word mole is a word that represents a number in exactly the same concept as a dozen represents a number. As we know, a dozen represents the number 12. And it's important to keep this in mind, that they do pretty much the same thing in terms of the concept. Now, why is that important? It's important because we need to be able to measure the amount of particles that are in a reaction. So knowing the amount of particles of something is very, very important in chemistry, right? The problem is that we can't measure that directly. We have to measure other things and change them into moles, and that the other things that we measure depend on the state of matter that we're dealing with, whether it's gas or solids or liquids. So we're going to take each of those in turn, and we're going to start with gases. So one of the things that we very often measure about gases is their volume. And one of the important pieces of information that we know about gases comes to us from Avogadro's law. And Avogadro's law tells us that it doesn't matter what the gas is. It could be hydrogen, it could be neon, it could be oxygen. If we have balloons of the same volume, they will contain the same amount of particles. So it makes sense then to ask the question, well, what volume of balloon would we have to have this amount of particles? And it turns out we know the answer to that. The answer is 22.4 litres, which we sometimes write as 22,400 centimetres cubed. Okay, so this is really, really important, because what this means is that we can change from volume into amount of particles now. That's really, really easy to do. All we have to do is divide the volume that we have by this magic number, 22.4, to get the amount of moles of something that we have. Or we can multiply the moles of something by 22.4 to get the volume that we have. Again, you may have seen this before. In fact, you have seen this before, because we've all drawn this triangle. It's supposed to be a triangle with 22.4 here, with volume here, and with moles here. And what this does is this gives us this information of how to convert between volume and moles of a gas. And that's really, really important. It's something I've said over and over again in class, that as soon as you hear volume, you are going to use this number, 22.4, sometimes written as 22,400, depending on the units we're using. Okay, so that's gases. What happens with solids? Well, the thing about solids is, when it comes to solids, we usually measure mass. And mass is usually measured in grams or kilograms. Typically, it's measured in grams. So, what's the problem? The problem is that atoms have different masses, don't they? So, oxygen atoms have a different mass to hydrogen atoms, for example. So, we don't have one magical number like 22.4 to solve all our mass problems. Instead, we have to use the periodic table, because the periodic table tells us what 1 mole of each of these atoms weighs. It tells us that 1 mole of hydrogen atoms weighs 1 gram, 1 mole of oxygen atoms weighs 16 grams. And this is really useful because obviously most of the time we're not dealing with atoms, we're dealing with compounds. For example, water, which is made of 1 oxygen atom and 2 hydrogen atoms. So if I want to know what 1 mole of water molecules weighs, in other words, how much water do I need to have this amount of particles of it? Well, what I do is I add up my atomic masses of oxygen. I've only got one of them in there, so 16 times 1. I've got 2 hydrogen atoms, so I'm going to multiply the atomic mass of hydrogen, which is 1, by 2. And that's going to give me a total of 18 grams. That tells me what 1 mole of water weighs. Now I can convert really easily between mass and moles by multiplying by this number known as the relative molecular mass of water. Or if I have a certain amount of moles of water and I want to know what that will weigh, all I have to do is divide by the relative molecular mass of water. And again, you'll be familiar with this from the triangle that we drew for that, where we had the mass here, the moles here, and the relative molecular mass here, like that. And this little triangle can help us to convert between mass and moles and mass very simply like this. Okay, so we're nearly there. The last thing we need to think about is actual particles. Sometimes we're actually asked about the amount of particles of stuff that we have. And it can help sometimes here to go back to our idea of eggs. So we know that 1 dozen eggs is 12. Okay, if we want to know how many eggs do I need if I have 3 dozen eggs, what do I do? Well, if it's 3 dozen, I'm going to multiply by 3 by 12, my dozen number, to get the amount of particles of eggs, which in this case is 36. Again, if I want to know how many particles of a gas I have, I multiply by the amount of moles I have by my molar number, 6 by 10 to the 23, to get the amount of particles. And again, I can do the opposite. If I have an amount of particles and I want to know how many moles they are, it's exactly as if I have 6 eggs and I want to know how many dozen that is. What do? I divide 6 by 12, and that's a half a dozen, isn't it? So it's the exact same thing here. I divide the amount of particles by the molar number to get the amount of moles that I have. Okay, so this should give you a rough idea of a mind map of what it could look like for moles before you start a moles question. If you understand each of these concepts, then you're able to and ready to start an exam question. And I'm going to make a video of that very soon. So I hope this helps, and I hope this has helped you a little bit to make a mind map for yourself. Try it at home yourself, try and make one and see how you get on. Hope this helped. Bye-bye.